Okay, so I'm going to be taking you through the third paper from the summer 2020 series, which was actually sat later on in 2020 because of the pandemic. This is paper 3, which is calculator. It's higher tier. Let's just get started straight away. This is a pretty tough paper, I think. So first of all, we're going to simplify this. We know it's indices, so you just add the powers, so it's n to the power of 8. This one you're going to subtract the powers. So for the C part, you're going to do 3 take away 2, which is 1. And for d to the power of 4 over d to the power of 1, you do 4 take away 1, which is 3. So you get c to the power of 1 d3, which is just c d cubed for that one. We're going to just solve this inequality. Just pretend it's like a normal equation. So I'm going to multiply both sides by 2. And then I'm going to divide by 5. And you can just leave your answer like this as 14 over 5. So you have to say that x is greater than 14 over 5. Number 2, it says Andy cycles a distance of 30 kilometers at an average speed of this, and he then runs a distance at 12 kilometers at a speed of 8 kilometers per hour. Work out the total time that it takes. So for the cycling part that we've got here, we can see that, remembering our distance, speed, time, distance, speed, and time, we know that time is going to be equal to the distance divided by the speed. So the distance is 30 kilometers and the speed is 24. So on my calculator, I'll just quickly work that out. So I'm going to do 30 divided by 24, which is 1.25 hours. And then for the running section, the time is going to be the distance divided by the speed. The distance is 12 and the speed is 8. So I'll do 12 divided by 8. 12 divided by 8, and you get 1.5 hours. So I'll find the total time. It wants it in hours and minutes. So the total time is 1.25 plus 1.5, which is 2.75 hours. And because it wants it in hours and minutes, I know that the 2 hours I can write down here. I just need to work out what 0.75 of an hour is. Now there's 60 minutes in an hour, so I'll do 0.75 times 60, and it will tell me how many minutes that is going to be. So it's 45 minutes, 2 hours and 45 minutes. Question 3, we've got the error interval now. It says when it's rounded to 1 decimal place, the number m is rounded to 1 decimal place, the result is 9.4. Well, if it was 9.35, it would round up to 4, and if it was less than 9.45, it would round down to 9.4. And you'll notice this one doesn't have the line underneath it, so it means anything up to the 9.45 would round down to 9.4. Question 4, Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn 10 meters by 14 meters. She has 5 boxes of grass seed. Does she have enough grass seed to make a lawn of 10 meters by 14 meters? You must show all your working. So she's got 5 boxes of grass seed, and there's 2 kilograms in each box. So the amount of seed that she has 5 times 2, she has 10 kilograms. Now we know from this beginning bit that 3 kilograms does 5 by 9. Now 5 by 9, if we're talking about the area, 5 by 9 is going to be an area of 45 meters squared. So we know that 3 kilograms is going to help cover 45 meters squared, and she has got 10 kilograms. So we'll find out how much that covers. Now to go from 3 to 10, let's find out what you need to multiply by. So I'm going to do 10 divided by 3. Great, we can just either say it's 3.33, or I can just say I'm multiplying this side by 10 over 3. I'm also going to then multiply this side by 10 over 3 as well. So I'm going to do 45 multiplied by that answer I had on the calculator, which is 150 meters squared. So this shows that Maisie can cover 150 meters squared. Maisie can make a lawn of 150 meters squared. She wants to do 10 by 14. She wants to cover 10 by 14. And 10 by 14 is 140 meters squared. So she has enough, because 150 is bigger than 140. Maisie opens the 5 boxes of grass seed. She finds that 4 of the boxes contain 2 kilograms of grass seed. The other box contains 1 kilogram of grass seed. Does this affect whether Maisie has enough grass seed to make her lawn? Give a reason for your answer. So we're going to go back to this line of working that we have here, and we're going to see how it changes. So instead of having 10 kilograms, she's got 1 kilogram less. So previously, 3 kilograms would do 45 meters squared. She's now got 9 kilograms, which is just timesing it by 3. So I'm going to times it by 3 over here. And we're now going to do 45 multiplied by 3, which is 135 meters squared. So actually, she doesn't have enough. So she would need 140 meters squared. So does this affect whether Maisie have enough grass seed to make her lawn? We can say yes. 9 kilograms only covers 135 meters squared. Now there's lots and lots and lots of different ways of answering this question. This is just the way that I decided to go approach it. You could have instead found out how many boxes or how many kilograms she would need to do 140 meters squared and compared it in that way. So there's lots of different ways you can answer this one. Okay, question 5. Amanda has 2 fair 3-sided spinners. She spins each spinner once. Complete the probability tree diagram. So the probability that it lands on a 2 in this one here, well, there's one way it can land on a 2 out of 3. And it does not land on a 2 is 2 out of 3. For spinner B, it's exactly the same stuff, landing on a 2 and not landing on a 2, landing on a 2 and not landing on a 2. You'll notice how each branches kind of look the same. Work out the probability that spinner A lands on 2 and spinner B does not land on 2. So first of all, we have an AND, which means it's going to be a multiply. We want A to land on 2, and then we want B to not land on 2. So the probabilities we're going to use is 1/3 and 2/3, and we're literally just going to multiply those together. So we're just going to do our 1/3 multiplied by 2/3. Of course, you can do this on your calculator as well, but we just get that the probability is 2/9. You don't need to write out the answer again, but I'm just going to write it on the dotted line anyway. Okay, question 6, really quick one here. It just says, use these graphs to solve the simultaneous equations. Well, we know that the solution to the simultaneous equations is where they cross over. So the x coordinate is -2 that you can see here, and the y coordinate is 4. So the solution is -2 and 4. We then have another kind of question here. It says use this graph to find estimates for the solution of the quadratic equation where the quadratic is equal to 0. So the quadratic is obviously the curve. When it's equal to 0 is when the y coordinate is 0. So we're trying to find out this point here and this point here, and I'm going to zoom in to help us find out what they're going to be. So the estimates are going to be, this one looks like it's going to be 0.6. And as we come over here, this one is 3.4. Now they'll give you like a range of answers that they accept for this, but I think we're going to say 0.6 and 3.4. So the solutions are 0.6 and 3.4. You could say x equals 2 if you wanted to, but I can just leave it like this. It's perfectly fine for us to leave it. Okay, question 7. It says there is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2, and the mean age of the 27 girls is 16.7. Calculate the mean age of all 45 boys and girls. So we've got 18 boys, and we know that each of them has an age on average, a mean average of 16.2. So to kind of go in reverse, we do multiplication. Remember with mean, you normally divide by 18 at the end. So we're going to take the mean and we're going to multiply it by 18. That will tell us the total age of all 18 boys. So we'll do 18 times 16.2, which is 291.6. And then for the girls, we're going to do the same thing. There are 27 girls, and each one has an average age of 16.7. So we'll do 27 times 16.7. I keep doing that on my calculator wrong. 27 times 16.7, which is 450.9. So this is the total ages of the boys, the total ages of the girls. So the total ages overall are 291.6 plus 450.9. And to find the average, we're going to divide the total ages by how many people there are, which is 45. So I'm going to do 291.6 plus 450.9. I guess I should have put this all in a fraction. And we're going to divide that by 45 so that we get the average for all of them is 16.5. And that seems like a pretty reasonable answer because this is the average here and the average here. So 16.5 seems good for it to be somewhere in between. Okay, question 8. There are some counters in a bag. The counters are either blue, green, red, or yellow, which we can see in the table. The table shows the probabilities that a counter taken at random from the bag will be blue or will be green. The probability that a counter taken at random from the bag will be red will be 5 times the probability that it will be yellow. So this one is going to be 5 times more than yellow. And then it says there's 300 counters in the bag, work out the number of yellow counters. Well, first of all, we need to remember that all of these probabilities are going to add up to 1. So I'm going to begin by doing 1 take away 0.32 and take away 0.2 to find out what red and yellow should be. So I'll do 1 take away 0.32 and take away 0.2, which is 0.48. So they said that the red is 5 times the yellow. Now, if you like thinking of ratio, we're saying that the red is 5 times the size of the yellow, or you could say that the red is like 5y, so you've got to figure it out from there. But I kind of like thinking of it in this diagram. So we know that 0.48 has got to be shared between these 6 boxes that we've got here. 0.48 divided by 6. And that will tell us how much one of the boxes is. So each of these little boxes that we have here is 0.08, which means the yellow is 0.08. And so the red is 0.08 times by 5. Oops. 0.08 times 5, which is 0.4. Plus, we could have told that they had to add up to 0.48. Now we're just going to work out how many of them are yellow. So you take the number of counters that there are in the bag, you multiply that by the probability of yellow. So you do 0.08 and you multiply that by 300. Because it's really saying that the probability is 8%, so you're actually finding like 8% of 300. So I can be lazy and do this on my calculator. 0.08 times 300 is 24. So there are 24 yellow counters. Again, you can write it on the line if you want to. Okay, question 9. The diagram shows a prism. The cross-section of the prism has exactly one line of symmetry, which is this part that we've got here. Work out the volume of the prism. Well, we know that the volume of the prism is the area of the cross-section multiplied by the length. Now we can tell that the length is 20, so I just need to figure out what the area of the cross-section is. Well, this bottom section is pretty easy, right? That's just 12 times 10, which is 120. So I'm going to concentrate on the triangle that we've got at the top, because that's the thing we're going to need to figure out. Well, we know that the base of the triangle is 10 centimeters. I need to try and find out what the height is, and I know that this is 40. So I'm actually going to draw just half of the triangle and see what topic this might be. So there's a 40-degree angle. That will be 5 along the bottom, and we're trying to find out what the height is. So maybe you've guessed, but this is SOH CAH TOA, okay? We have got the opposite over here. That's the one that's opposite the angle, and we've got this one which is adjacent to the angle. And out of SOH CAH TOA, the one that uses the opposite and the adjacent is TOA. So I'm going to say that the tan of 40, the tan of the angle, is the opposite, which is the height, divided by the adjacent, which is 5. So I'm going to do 5 multiplied by tan 40, and that's going to tell me the height of that triangle that we've got there. So 5 multiplied by tan 40 is 4.195. I'm going to just write a few of those numbers out so that I can do it correct at the end. 4.195. So the height is 4.195 centimeters. So going back to this diagram that we've got over here, we now know that the height is 4.195. So I can find out the area of the triangle. The area of the triangle is a half multiplied by the base multiplied by the height, which is 4.195 that we have here. So on my calculator, I'm going to keep the full version as the answer button. I'm going to do a half multiplied by 10 multiplied by the answer, and we get that the area is 20.977. I'm just going to leave that in my calculator. So we now know what the area of this top section is as well. It's this 20.97. So I've actually been able to work out the area of this cross section because I can just simply add these two numbers together, the 20.97 and the 120. So I'm going to go to my calculator and I'm going to say that the cross section area, which was this shape, is the 120 plus the 20.977 number. So I can go to my calculator, I can say, right, I want you to add 120 onto that answer, which is 140.977. And then we're going to use the volume formula that we said at the top, which was the cross section times by the length. So that's 140.97 multiplied by the length of this shape, which we said was 20. So I'm going to multiply that by 20. And luckily I've got that stored on my calculator already. So I can just say it is equal to the answer. Oops, I think I've plussed 120 to it twice. So we'll do 140.97. What am I doing here? 140.97 multiplied by 20. So it only wants it to 3 significant figures. So that's, at the moment, it's 2819.4. 3 significant figures. You're going to draw that line in there. Okay, the 9's going to make it round up. So it is 2,820 centimeters squared. But actually, they aren't accept it if it was 2,810 if you did some rounding earlier on in the question. Okay, quite a lot going on in that one for a question 9. Okay, question 10. A person's heart beats approximately 10 to the power of 5 times each day, and a person lives approximately 81 years. Work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form correct to 2 significant figures. Okay, so it's an estimate here, which means we can do some rounding. Even though we have a calculator, we can still do some rounding for this. They actually really want you to do that kind of rounding. So I think we could say that if there are there's 10 to the power of 5 times each day. In 1 year, there would be 10 to the power of 5 times 365. And in 81 years, we would multiply it by 81. But I'm going to approximate this. So I'm actually going to do 10 to the power of 5. I'm going to multiply that by something. Instead of 365, I'll round it to 1 significant figure, to 400. And instead of doing 81, I'm just going to times it by 80. So that's 10 to the power of 5 times by the 4 times the 8. In fact, I can just do this all on the calculator, can't I? I can do 10 to the power of 5 multiplied by 400 multiplied by 80. And so it's 3,200,000,000. So let's actually just go straight to this answer. So it is 3, 2, 1, 2, 3, 4, 5, 6, 7, 8. My calculator, I've set it up so you can have the commas in there. So it wants it in standard form. It's already to 2 significant figures. So it is 3.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 3.2 times 10 to the 9. That's the number of times that we think a person's heart would beat over their lifetime. And there's a range of answers they would accept for this, depending on how you did your estimation. 2 times 10 to the power of 12 red blood cells have a total mass of 90 grams. Find the mass of 1 red blood cell. So altogether it is 90, and there are 2 times 10 to the power of 12. So I want to find out how much it is for 1. So I'm going to divide it by 2 times 10 to the power of 12. And it's going to want us to give our answer in standard form. So what you can do here is you can do in standard form, you can just do 90 divided by 2, and then you can press this button at the bottom. Mine comes up with an E, but your calculator might do times 10 to there. And you can do that division, and it comes up with 45 times 10 to the power of minus 12. Now that looks like it's in standard form, but it is not, because this first number needs to be between 1 and 10. So I'm going to divide that bit by 10, which means that I need to multiply this bit by 10 to balance it out, which actually means just increasing the power by 1. So minus 12 increases to minus 11. So the mass of 1 red blood cell is 4.5 times 10 to the power of minus 11. Okay, question 11, it says we have the diagram shows a triangle P on a grid. The triangle is rotated 180 degrees about the origin to give triangle Q. The triangle Q is then translated by 5, 2 to give triangle R. Describe fully the single transformation that maps triangle P onto triangle R. Well, first of all, I think we should try and figure out where triangle Q ends up. Now, if you had tracing paper, this would be a lot easier. But I'm going to find out when you rotate it about 0, 0. Sorry, my iPad just jumped around. I'm going to draw where Q is, okay? Well, I think if it's going to rotate around here, this point is going to go all the way to this side. and then I'm going to draw in triangle Q. It's rotated, so that part is coming downwards, and then it's going across, and then it's coming up like this. So this is triangle Q that we've got. Now it's being translated by 5 minus 2. This means that it is going 5 to the right and 2 downwards. Negative means downwards and negative means left. So this positive 5 means that it's going to the right. And I'm actually just going to concentrate on where this cross moves. I'm going to move it 1, 2, 3, 4, 5 to the right, and then 1, 2 down like that. I'm now going to redraw that triangle in place so that it looks like it's here. And now we want to describe where triangle R, how it's related to triangle P. Now there's a couple of different ways you could do this. You could say that it was an enlargement with a negative scale factor, but I think the most obvious one is that it looks like P and R has been some kind of rotation, and the rotation is 180 degrees. But the hardest part is going to be about thinking about where that center of rotation is. So I'm going to connect these two things together, and then we can see where the center, where the midpoint of this line will be, because that will be the center of the rotation. You can visually see that this is it here, and you can see that it's there because it's going 3 across in that section, so half of that will be 1.5, and you can see here to here it's coming 6 down, so halfway will be 3 down. So this bit is going to be the center of rotation. So all we need to do now is we need to describe this, and it wants 3 marks, so you've got to be really careful about the way that we describe it. It is a rotation of 180 degrees, and we have to tell them what the center is, and the center is 2.5 along and 1 down, so it's 2.5 minus 1. It then says, under the transformation that maps triangle P onto triangle R, the point A is invariant. So there's one point in this whole thing that doesn't move at all, and it's the center. If you think about where you would do with tracing paper, the point that doesn't move is where you would put your pen. So the center is the point that is invariant. So it is 2.5 minus 1. Okay, 12a, express this as a single fraction in its simplest form. So we have x brackets x plus 2 plus 2x over x minus 4. Now to get a common denominator, we want the common denominator to be x plus 2, x minus 4. So that means this one needs to be multiplied by an x minus 4 to get that common denominator. And this one needs to be multiplied by an x plus 2. So we get a 2x brackets x plus 2. Now I'm going to just go about by expanding everything on the top, see if we can do any simplifying. So we get x squared minus 4x plus 2x squared plus 4x. Okay, that seems pretty good because you can see here the 4x and the 4x are going to cancel. Obviously, I've still got my denominator that we have here, and the denominator is still our x plus 2, x minus 4. Now, I'm not going to expand that. The reason I'm not going to expand that is because the numerator just simplifies to 3x squared. I don't think there's anything that we could do. Expanding the denominator isn't going to mean that anything is going to cancel at all. So we can leave it like that. But if you did expand the denominator and you got your x squared minus 2x minus 8, if you had that in the denominator, that's obviously perfectly fine as well. This one wants us to expand and simplify this. Now, I'm probably going to do these two bits first, and then I'll multiply it by the x minus 3, but you could do it in any order. So I like doing the grid for this. I find the grid can be a really effective way of just keeping it nice and tidy. So I'm going to multiply all of these parts together. I'm going to get 8x squared here, 12x, 10x, and 15. So this is all going to simplify to 8x squared. The 12x and the 10x that we have here is going to be 22x, and then we have 15. So that part now needs to be multiplied by the x minus 3. So this whole thing here now needs to be multiplied by x minus 3. And this is where the grid method is definitely going to be the best one. So I'm going to put along the top or the side, it doesn't really matter. I'm going to do 8x squared plus 22x plus 15. And then along the side, I'm going to do my x minus 3. So filling everything in this grid, I'm going to get 8x cubed, 22x squared, 15x. minus 24x squared, minus 66x, and minus 45. Obviously, you could do any of the numbers if you wanted to. So simplifying this, we've got the 8x cubed to begin with. And then we've got the 22 minus 24. 22 take away 24. Again, you can check it on a calculator, is minus 2. So these ones have simplified. And then you'll spot that these ones can simplify. So I'm going to be lazy. I'm going to do the 15 minus 66 for this. And that is minus 51. So it's minus 51x. And then we've got the minus 45 at the end. Not particularly pleasant, but if you use the grid method, I think it makes it a lot easier. Okay, on the grid below, by shading, the region that satisfies all these equations, label the region R. So we're going to use the region R that we have for this one. So first of all, we're going to do these all as lines. We're going to say the line x equals 0. Now the line x equals 0, I'm going to do with this straight line tool that I've got here. This is the line x equals 0. In fact, I'll do it in a slightly thicker pen because everywhere along here has an x coordinate of 0. My next line that I'm going to look at is that x is greater than 2. So I'm going to look at the line instead, x is equal to 2. We'll come back to it in a second. So if x is equal to 2, this is it here. Now I have this line, which is y equals x plus 3. That just means it has a gradient of 1 and a y-intercept of 3. So when I draw this line, I want it to go through 3 that we have here, and I want it to have a gradient of 1. So it's going to look something like that, okay? So you could do this probably a little bit neater than me if you have your ruler. Let's do it in blue, like that. So that's this one. That's this one, and that's this one. Our last one is this trickier one. This is 2x plus 3y equals 6. We're going to do a sneaky thing here. We're going to find out how to draw this line because we can test and make up some coordinates. So if x is equal to 0, we would get that 3y is equal to 6 because I'm saying this thing here is 0. And if 3y is equal to 6, then y is equal to 6 divided by 3, which is 2. So we have a coordinate which is 0, 2, and I'm going to plot that. 0, 2 is over here. If y is equal to 0, going back to this equation, you would get that 2x is equal to 6, which means that x is equal to 6 divided by 2, which is 3. So we have the coordinate x is 3 and y is 0. So now that we've done that, we can actually just plot the line by joining those two things together. So when you join those two things together, I still want to do it in blue, you get this kind of thing. And that is this equation that we have down here. So what we need to finally do for this pretty horrible question actually is to think to ourselves, which region are we talking about? So we want to shade in, wants it to satisfy all of these. We want to say that x is greater than 0 and less than 2. So we're actually talking about this kind of in-between zone of those two lines. We want y to be less than x plus 3. So that means we want y to be less than. That means we're going to go underneath this line. So I'm going to just say we want it to be underneath this line. And here we want 2x plus 3y to be greater than 6. So we want this part, we want the line to be above. So that means for this diagonal one we've just drawn, we want it to be in this like above section. Now the only place where it's true for all of them is this bit that we have right here. So this is the part that we would shade, and we're going to label that this is R, okay? It is in between these two lines, it's below this line, and it's above this line. This is the only one that works for absolutely all of them. 4 marks because there's a lot of work on this. Okay, part B, the diagram below shows the region that satisfies these inequalities. Jeffrey says that the point with coordinates 2, 4 does not satisfy all the inequalities because it does not lie in the shaded region. Is Jeffrey correct? Well, they have plotted all of these correctly. It doesn't say that there's a mistake. He just says that 2, 4 doesn't satisfy it. So we're going to have a look at the coordinate 2, 4 and see what we think. 2, 4, well actually 2, 4 lies on the boundary and the boundary is included. The reason that the boundary is included is because of the fact that these signs say or equal to. If they just said equal, If they said greater than, then it would be a dotted line. But you can see on this diagram here, all of the things are solid lines, and you can see from these equations that they're included. So he is actually incorrect because it is on the boundary, which means it is included. So is Jeffrey correct? No, and we can say 2, 4 does satisfy it because it's on the boundary. Does satisfy because it is on the boundary. I'm actually going to use the word included boundary because that line is also included. Okay, I'm just going to see if there was any other way that they usually sort of say this. Just checking it in the mark scheme. Yeah, that's fine actually. The way that we've written that states included. Something that they say in the mark scheme for this is 2, 4 lies on the boundary of the region satisfying the inequality sign. So that's perfectly good. Okay, question 14. Points B, D, E and F lie on a circle. Great, we can see that. ABC is the tangent to the circle at B. Great, we can see that. And then it says find the size of angle ABD. So the thing that we're aiming for is to get to this angle that we have over here. And it says you must give a reason for each stage of your working. So the first thing that I noticed from my circle theorems is that I have this shape, which is a cyclic quadrilateral. And hopefully you remember that opposite angles in a cyclic quadrilateral add to 180. So what I mean by the opposite angles is this angle and this angle must add up to 180, meaning that that one is 80 degrees. So now that I've put up my diagram, I'm also going to just label it, and I'm going to say that DBF, angle DBF is equal to 80 degrees. And the reason that we're going to write for this, and you have to say this, opposite angles in a cyclic quadrilateral. Now that is actually enough to get that communication, but we're going to just do the last part, which is going to say add up to 180 degrees. Now I can see a different shape going on. I can see this triangle that I've got here, and we know how to find the other angle in a triangle. One is 80, one is 40, so they add up to 120. That means this one over here must be 60 degrees. So that means that angle BFD is equal to 60 degrees. And this is because angles in a triangle, that's enough to say angles in a triangle, but we're going to do the whole thing. Angles in a triangle add up to 180 degrees. Now actually we can go straight to what the answer is. ABD is 60 degrees, and this is because this angle and this angle are equal because of the alternate segment theorem. Okay, if you don't know that, it's something you're going to have to look up as well, and I'm going to be doing some videos on that very soon as well. So angle ABD is equal to 60 degrees, and this is because of the alternate segment theorem. You don't need to say the word theorem. If you just said alternate segment, that's perfectly fine too. So the answer to that was 60 degrees. Prove algebraically that 0.73 recurring can be written as 11 over 15. So I like just to remind myself, this means 0.73333. It just goes on and on and on. So we're going to start off by saying let x equal that number that we've got. Now I'm going to times this by 100. Well, let's start off actually, let's times it by 10. So we get 7.333 recurring. And that's going to go on forever. If I times it by 10 again, or if I get 100x, times it by 100, I get 73.333 recurring. Now what I'm going to do is think, how can I get rid of this long trail of 3's here? I'm not going to use the first one. The way I can get rid of that is by doing 100x, take away 10x. That would be 73.333 recurring. Take away 7.333 recurring. All the 3's are going to get rid of each other. I'll be left with 90x on this side, and I'm going to be very lazy and do 73, take away 7, because all of the green 3 parts are going to disappear, which is just 66. So x is 66 over 90, and 66 over 90 is 11 over 15. So this is the proof part that we're looking for over here. Okay, question 10. Here is a speed-time graph for a car. Work out an estimate for the distance the car travelled in the first 30 seconds. So in speed-time graphs, to do these estimates, the distance travelled is the area under the line or the curve. But because it only wants it to be an estimate, we're not going to find out the perfect one. We're actually just going to pretend that in the first 30 seconds that we have here, we're just going to pretend that it is a triangle shape instead of a curved shape. So I'm just going to find out what we think that's going to be. Well, it looks like this number that's at the top here, I haven't drawn it perfectly, looks like that's in between 8 and 10. It looks like it should probably be 9, okay? So mine's probably not gone up quite high enough, but it looks like this length of the triangle is 9 and the bottom is 30. So the area under the curve is going to be the distance travelled, that is the base times the height divided by 2 because it's a triangle. So I'll do 30 times 9 divided by 2, 30 times 9 divided by 2, and we get 135 metres. Okay, they will accept a different sort of range of answers for this, but I think 135 probably seems to be like the most reasonable one that we have. It then says, is your answer to part A an underestimate or an overestimate of the actual distance car travelled in the first 30 seconds? Well, we worked out this triangle area, but there's this little extra bit of area. So our answer is an underestimate because because of the curve that is above it. So we could say something that like, it's an underestimate because the area between the triangle and the curve is not included. So ours is an underestimate because the area between the curve and the triangle is not included. And the bit I'm talking about is this section in here. Okay, Julian used the graph to answer this question. Work out an estimate of the acceleration of the car at time 60 seconds. Here is Julian's working. Acceleration equals speed divided by time. So they did 13 divided by 60 and then got the answer. Julian's method does not give a good estimate of the acceleration at time 60 seconds. Explain why. Well, at 60 seconds, what they did, they went here and they just said, great, I've got 60 and I'm going to divide it by 13. Now, hopefully you remember what you should do for this. You're supposed to draw a tangent at that point and then find the gradient of the tangent. So actually, Julian was finding this gradient of this laser line that I'm drawing here, but should have been finding the gradient of this bit. So probably the best way to say this is that Julian should have drawn a tangent. So I'm going to say here, explain why. Julian should have drawn a tangent at 60 seconds before finding the gradient. Okay, should have drawn a tangent, should have used a tangent, something like that. Okay, question 17. The histogram gives information about the distances 80 competitors jumped in a long jump competition. So it doesn't say the frequency along the side, it says the frequency density, and we know that there are 80 competitors. So calculate an estimate for the mean. Okay, well normally the estimate for the mean is when we have a grouped frequency table. So I think what we're going to need to do is actually construct a table here, and then we'll look back at the histogram in just a second. So you don't have to worry too much about what the groups are like, but if I just say that the distance, well, the first part is going to be 6.4 to 7.2, I'm just looking at this. We then got 7.2 to 7.6. I could use the proper inequality signs, but we don't need to, I'm just being lazy. 7.6 to 8, and then we have 8 to 8.2. Okay, so we're now going to try and find out some of these other things. We actually want to find out what the frequency is. Now, to find out the frequency, hopefully you can remember that the formula to find out the frequency is equal to the density multiplied by the class width. So I'm going to do lots of drawing on the diagram here, okay? The density here is 10, and the width along the bottom, 6.4 to 7.2. 6.4, let's do 7.2, take away 6.4, being very lazy, is 0.8. So the frequency, and you can label this, is going to be 10 times 0.8, which is 8. I'm going to do the same thing on this next section. This looks like it is going to be 50 is the length of this part that we've got here, and the gap along the bottom is 0.4. Ooh, let me just put this in the table. So we've got 50, we've got 8. Now we're going to do 50 times 0.4. That means this section represents 20 people, or 20 Yeah, 20 competitors. Okay, let's put this to the other side. We're now going to see if we can work out what the, I'm going to put the calculator back over here actually. This is 100 all the way from the top to the bottom for the next bar. That's the frequency density and it's 0.4. So I'll do 100 times 0.4, which is 40. So that represents 40. And then this last part that we've got here is 0.2 and it goes up to 60. And 0.2 times 60 is 12. You also could have figured out how much one single square is worth. A single square is 0.2 times 10, which means each square is worth 2. So you can see you've got 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is double this one because it's double the area. 2, 4, 6, 8, 10, 12. So you can see the area is actually representing the frequency. So the area is the frequency. Okay, so now we've got this. We've got our 20, we have our 40, and we have our 12. We're now going to change this into an estimate of the mean. So to do that, we take our midpoint and we're going to multiply it by the frequency. So we're going to do the midpoint times by the frequency. The midpoint of the first group, you can kind of visually see it, is 6.8. The midpoint of the second group between 7.2 and 7.6 is 7.4. We then have 7.8, we're talking about the middle of these things, and our last one is 8.1. So I'll do the midpoint times the frequency for this. So I'm going to do 8 times 6.8, that's 54.4. 20 times 7.4, so 148. 40 times 7.8, 312. And 12 times 8.1. 12 times 8.1, I made a mistake there, 97.2. Now, we add up all of those numbers, so that's 54.4 plus 148 plus 312 plus 97.2, 611.6. We know what the frequencies add up to, which is 80, so I'm just going to do, my final calculation is 611.6 divided by 80, so equals that divided by 80, and we get 7.645. Now, I don't think it wants any rounding at all, so I'm just going to write 7.645. Did it want any rounding? Let's just have a quick. No, it just says calculate an estimate for the mean distance. So you could round it if you wanted to 7.65, but I would leave it as 7.645. Okay, question 18. The diagram shows a cube. AH is 11.3 centimetres, correct to the nearest millimetre. Well, in millimetres, that is 113 millimetres. I think it's annoying that they've said centimetres and millimetres. Now they've said AH. AH is between A and H. It's this diagonal part that we've got here. Now hopefully you can see that this is the diagonal. It's actually coming from Pythagoras in 3 dimensions. So when we're talking about it in 3 dimensions, we're trying to find out what this length is. Now they've said that this length is 113. Now there's a shortcut for doing the diagonals. The shortcut for the diagonals is you can look at the three like coordinates between them. So you're going from A to D, then from D to C and C to H. All 3 of those things are the same length. We have X, X, and X. So if you ever want to find the diagonal of something that's in 3 dimensions, you take the 3-dimensional measurements, you square them, add them, and square root them. So we know that if you were going to try and find that diagonal length, you would do squaring all 3 of them. Normally with Pythagoras it's 2, but Pythagoras in 3D is all 3 of them. And we are going to actually read what the question says, which says calculate the lower bound for the length of an edge of the cube. So we're going to try and find out what the length of the edge of the cube is, but this thing has been rounded to the nearest millimetre. Now, because we want the lower bound, we're going to say, what's the smallest thing that this could be that would still round to that? And it is 112.5. So I'm going to find out what this is by squaring both sides. So I'm going to do 112.5 squared. I'm just going to write it as 112.5 squared, just going to save some time. And that will get rid of the square root on this side that we have here, so that can then just be ignored. So we are left with 3x squared. So x squared is going to be 112.5 squared divided by 3. which means that x is the square root of 112.5 squared over 3. That's going to be the lower bound because we did the lower bound of this. If we wanted to do the upper bound, we would have done 113.5. Okay, so I'm going to just do on my calculator. I'm going to do the square root of 112.5 squared over 3. And we get the lower bound. My calculator's not going to jump all the way around like that. Doesn't want it to any particular value, so I'm going to write 64.9519. I think that's enough decimals. I'm just going to see what they say. Yeah, they just want something between 6.49 and 6.5. You could write more numbers if you want to. They've got in the mark scheme, it goes all the way up to this, but 64.9519 is definitely more than enough for this. Okay, we're getting to some really horrible final questions. I think we've got question 19, 20, 21 left. So we've got 3 questions, and they are pretty horrible, particularly question 19. So ABCDEF is a hexagon with side length x. So this one that we've got here, this little one, has side length x. And then the hexagon is enlarged with center F by scale factor P to give this other hexagon. Show that the area of the shaded region is given by this. Okay, well, let's not worry about the big hexagon. Let's worry about the small one. Then I think we can use that to find out the big one. Then we can subtract them and find out the shaded area. So thinking about the small one, a hexagon is actually some triangles. So I'm going to change this question and just find out the area of one triangle, okay? I'm going to try and find the area of, I don't know, let's just do this bottom one that we've got here. I'm going to draw it to the side of the page and see if that will help us. That's not very well drawn, nor is that, but we'll stick with it. So because it's x here, and because it's a regular hexagon, this would also be x, and this angle that we would have here would be 60, because these triangles must all be equilateral triangles. We have x, and it's 60 for an equilateral triangle. So for the area of a triangle, the area of one of the small triangles, we can use a half AB sine C, which is going to be a half times x times the sine of 60. So I'm just going to do, on my calculator, I'm going to do the half. I'm not going to obviously type in the x squared, but I am going to multiply by the sine of 60. And I'll press SD, and we get root 3 over 4. So one of the triangles is root 3 over 4 x squared. And notice how I'm not going to press the SD button, because it all looks like this. So now I'm going to work out the area of this hexagon by multiplying it by 6. So the area of the small hexagon is equal to 6 times by root 3 over 4 x squared. So I've already got that root 3 over 4 on my calculator. I'm just going to multiply that answer by 6, which is 3 root 3 over 2. That's probably how your calculator will say it. It will probably say 3 root 3 over 2 x squared. You can see that this 6 and this 4 have simplified to the 3 and the 2. Now we're going to think about the area of the large hexagon. The area of the large hexagon, well, they've said that the scale factor is P. So the length scale factor is P, but we're talking about area. The area scale factor will be P squared. So that means that the area of the large hexagon is going to be 3 root 3 over 2 x squared multiplied by P squared. So in fact, I'm going to write 3 root 3 over 2 P squared x squared. So we're nearly there. We're now going to do the shaded area. The shaded area is the larger area, 3 root 3 over 2 P squared x squared. Subtract the smaller area, which is 3 root 3 over 2 x squared. And we're just going to see if we can do some factorising. So I'm really happy we've got this. So I'm going to take out 3 root 3 over 2 x squared. They both have that. This first part, though, has an extra p squared. So I'll write p squared. This is just exactly here. So I'm going to write p squared minus 1. The only thing they've done differently is they've put the x squared at the very end. So I'm just going to rewrite it. And I'm going to say it is 3 root 3 over 2 p squared minus 1 x squared. Pretty tough question. Looks tough, but I actually think It blends so many things: area scale factors, half AB sine C, equilateral triangles, hexagons. There's a lot going on. Okay, question 20 is pretty nice actually. It's pretty simple. It says, here is a list of 5 numbers. Find the lowest common multiple of these 5 numbers. Now, the lowest common multiple, if you've watched my videos on this before, when you're comparing numbers, it's like which ones have the highest power. So this one is going to be the lowest common multiple because it has the highest power. If, which we're not, we were doing the highest common factor is the lowest power that they have in common. So the highest common factor would have been 98 to the power of 53. Looks like a very unusual question, but if you use your ideas of highest common factors and lowest common multiples, you should still be able to come up with this. Okay, I believe this is the last question. Yeah, and it's a pretty tough one. Well, part B is tough, but 21A is kind of okay. So it wants us to find the ratio C to D. Well, at the moment we have an equation which is 5C plus D equals C plus 4D. Let's just make it look like a normal kind of equation that we've got here. So I'm going to try and make C and D all on one side. So if I get rid of this C, I'm going to subtract it so that I get 4C plus D equals 4D. And I'll get rid of this plus D by subtracting it, so I get 4C equals 3D. Now, we're trying to find the ratio C to D. You might go, oh great, I've got it, and it's got the 4 and the 3. But actually, it's the other way around to how you would expect it. It's actually the ratio 3 to 4. The reason you can think of this is because if you divide both sides by 4, you get that C is 3/4 of D. C is 3/4 of D. If I find 3/4 of 4, I get 3. If I find 3/4 of 4, I get 3. So that's why C needs to be smaller than D because of this line. It looks like you're going to do 4 to 3, but it's actually 3 to 4. Okay, here is a horrible question. It says x is greater than 0 and y is greater than 0. We have this thing here, find the ratio x to y. So we kind of want to come up with something that looks like this, but for this part. So I don't know how anyone would have done in this because I think this is pretty nasty. So there are a couple of ways of approaching this, but the way I approach this is I think, okay, this is kind of making me think of a quadratic. So what I'm going to do is I'm going to put everything all onto one side. I'm going to have my 6x squared minus 7xy and minus 20y squared. And this is where you have to be able to hope through some trial and error that you might be able to factorize this expression that we've got here. So the way that this actually factorizes, and this is why it's the last question, is for the 6x, there's going to be a 2x and a 3x. And then you're thinking to yourself, well, how am I going to get this 20y squared? Well, it's going to be with a 4y and a 3y. It's actually going to be with a 4y over here and a minus 5y over here. Now, this is pretty hard to spot, right? But we do get the 6x squared minus 15xy plus 8xy. And minus 15 plus 8 gives you minus 7. And then you do get the minus 20y squared over here. So you'd need to get lucky in spotting this. There are some other sort of factorizing techniques, but they kind of take a long time for me to explain, and I just want to kind of wrap up this rather long video. So this tells us that either this thing is equal to 0, so 2x is equal to 5y, or 3x is equal to minus 4y. But it says that both x and y are greater than 0, so that one won't work. This is now really similar to what we had up here, where we had this line. So the ratio of x to y isn't 2 to 5, but it is 5 to 2. It's the other way around. Let me just make that 5 there look a little bit neater. Okay, so I think that's a pretty difficult question to be able to spot that factorizing process that you've got. I guess you could also try and do it with some like numbers and substituting things in, but it is not particularly friendly. I guess you could try it. That's probably the one I would suggest. You could say like, I don't know, x equals 5 and then actually work it out from there. But this is probably, you know, it's on the last question for a reason. Really tough exam paper. I hope that this has helped, and good luck with all of your studies.